Right, so this is a summary of my presentation. I'm going to make a very brief presentation about my university, and then I'm going to talk about what design science research is about. And then I'm going to emphasize two topics: the research process involved in design science research and the typical outcomes, what you can get at the end of a research project in which you use design science research. I'm going to show some examples of research studies, examples of research processes, example of outcomes. And at the end, I will talk about the benefits you can get by using design science research and also some risks that you might face. So this is a map of South America, and you can see where I am by that red thing. And this is a picture of Porto Alegre, the city where I live. So it's a city with 1.4 million people. It's the capital of the state of Rio Grande do Sul, which is the most southern state of Brazil. So these are some numbers from my university. We have 2,200 faculty. 90% of them have a PhD degree, and around 30,000 students. 2/3 are undergraduate students, and 1/3, more or less, are master and PhD students. So my university is a university that is very much focused on research. So we have many postgraduate programs, many labs in different areas. And I'm part of the School of Engineering, which is one of the largest units from my university. I work in a group called NORI. NORI means Building Innovation Research Unit. It's a group that involves around 40 people, 9 academic staff, plus PhD students, master's students, and also some undergraduate students who work as research assistants. And we've been involved in research on lean construction for a long time. I'm a member of the International Group for Lean Construction since 1996. And it's like the main topic, the main research topic we work in our group. So we are quite used to develop research for implementing managerial models, measuring performance, and measuring the impact of the implementation of lean construction. We are very much interested in organizational learning to see how companies learn the barriers for them to implement lean construction. These are some topics that we've been involved. We have a lot of experience in implementing the Las Planas system. I think more than 200 companies have worked with us in the implementation of Las Planas. We've been working with some topics like visual management, location-based planning. We also working a lot on the synergy between BIM and Lean, especially applied to the management of prefabricated building systems. Right? So these are just examples of topics. And because of this focus on implementation, learning, changing the industry, we got interested in design science research. So design science research is a different approach for doing research in which we make contributions that can help the industry to develop. In order to understand design science research, it is very important to explain the traditional way of producing scientific knowledge, right? And we can divide the traditional academic research in two large areas or large categories of sciences. First, we have the natural sciences like physics, biology, chemistry, geology, and so on. And the aim of natural science is to discover laws or theories that can explain or predict the behavior of natural phenomena, right? So this is the main idea. Discover these laws and theories that are applicable anywhere in the universe. So in natural science, there is this idea of developing theories that are universal. They work everywhere. In social sciences, which is a much more recent area of research, the aims are very different. So the aims of social science is to understand and interpret human experience. There are many differences in terms of research methods between natural sciences and social sciences. For instance, in natural sciences, research methods are mostly positivistic. The researchers, they place themselves as external observers. And there is a high level of consensus about research methods. This consensus is so great that usually research on natural sciences, they don't discuss a lot research methods. You don't find many books on research methods in natural sciences. By contrast, in social sciences, research methods are mostly qualitative, non-positivistic, and there are many competing conceptual frameworks. So there are very different ways to develop research in social sciences. Although these are two very different categories of sciences, they have something in common. Which is both natural and social sciences have as a mission to describe, explain, and possibly predict a certain phenomenon that exists in the world. So that's why we call those two areas of science as descriptive research. So the aim is to describe, understand, discover some laws that enables you to predict what's going to happen, right? So what's the problem with that research approach? The problem is that in our field, engineering, construction management, only understanding the problem is not enough. It's halfway. We need to solve it. So what happens in the field of engineering sometimes is that some people develop descriptive research. When it comes to solving problems, this is done only by practitioners, right? So the academics, they don't get involved in the development of solutions for the important problems in construction management. So what is design science research? Design science research, I'd like to call it a third category of sciences. The first category is natural sciences. The second one is social sciences. And the third is design sciences, right? So it's not a specific research method, but it's a different way of doing research. What is the main difference? It is prescriptive. So we want to prescribe things rather than describe the world, find the general laws and theories, right? So when we say prescribing something, it means that we create something new in the world, or we want to do some kind of improvement, right? That's why it has so much to do with construction management, implementation of continuous improvement, and so on. So it occupies a kind of middle ground between descriptive theories and practice, right? So it we in design science, the aim is to produce scientific knowledge, but this knowledge is not as abstract as it is in natural sciences. So some people call, for instance, mid-range theories. We produce mid-range theories, theories that are not at the level of the practitioners, but they don't, these theories are not intended to be universal, right? So they are applicable to a limited range of situations. Another characteristic of design science research, differently from the natural sciences and the social sciences, is that it usually involves a combination of social systems and technical systems, right? When you look at natural sciences, is the science of the things. These are the sciences of understanding things in the universe. Social sciences are the sciences of social systems. So we understand people, we understand social systems, companies, communities, and so on. In design science, we mix them. So we have a mixture of people, of organizations, and a mixture, and of course, physical things. For instance, if you do research on construction planning and control, you're interested in engineers, foremen, workers, subcontractors, but you're also interested in crane, in concrete, bricks, and so on. So we need to do with this mixture of things and people. There are different names. The most common name that is used nowadays is design science research. Some people also call constructive research. You find that in some papers. Constructive has not to do with the construction industry, but it's because of in design science, you produce a construction as an artifact, right? And another name is prescriptive research. So what's the origin of design science research? Where has it started? In different fields of research for different reasons, right? One of the fields is information systems and technology, right? This is a field that, probably the field that uses design science research most, more than other fields of research. And one of the reasons is that it's an area which is very much related to solving problems, developing software or hardware solutions. So design science research has been used as a way of creating more abstract research, right? So the idea is not only to solve specific practical problems, but to solve classes of problems that need solutions. Another field that has many papers published is cost accounting, which is part of the field of management, and also management in general. And it's interesting because the motivation for using design science research in the field of management is completely different from information systems and technology. The main reason is that many many studies published in design science research have not, many studies developed in the field of management, they have been criticized for not being relevant. So the strategy of adopting design science research is to make management research more relevant, more applicable to companies, to organizations. And there are also other fields for the application of design science research. I would mention medicine. Medicine is a field that produces descriptive research, for instance, anatomy, physiology, understanding how the human body works. But at the same time, there are lots of academic studies that are prescriptive, devising procedures, treatment, and so on. Pharmacology, for the same reasons. Education, so there are many studies about learning, how children learn, how adults learn, and so on. But there are also research on the development of research approaches. Can you hear me well? Just to confirm.
Yes, all good, Dr. Carlos.
Yeah, okay, thank you. More recently, design science research started to be used in design, engineering, and architecture, which are areas very connected to us. And in engineering, I would point out the area of industrial engineering has been using a lot of design science research. And construction management is also an area in which there is a growing popularity of design science research. And it's interesting because this is particularly strong in the lean construction academic community. So there are many people, many researchers, academics that are members of the International Group for Lean Construction that have been using design science research. But it's growing a lot. Also in the field of architecture, it's a field that traditionally adopts descriptive research, and now I've seen a number of studies using design science research. The case of construction management is quite interesting because at a certain point there was a discussion which kind of science is construction management. And I remember some people argued, there were some papers published in a very prestigious journal called Construction Management and Economics. And some people from that who published in that journal argued that construction management is a kind of social science. And I think this argument has been, let's say, there is a counter argument that construction management is not social sciences, but it is a type of design science. Should be using design science research. And one argument is obvious. We deal with a mixture of things and people, social systems, and at the same time, we do research mostly for solving problems. So what are
Sorry, Dr. Carlos. I just want to remind everybody to put your questions in the designated question and answer box, not in the chat box. We do have one question that is relevant at this point It was posted in the chat box. If you don't mind, I would like to read it for you, Dr. Carlos.
Okay, that's fine.
Riyadh is asking to let me understand the difference between natural research and design science research. Can you please give two examples? And he's referring to more to medicine and drug and natural research.
Yeah, of course. Yeah, for instance, there are a number of theories that in natural science that can explain the position of stars and planets and so on. So we can predict where a certain planet is going to be tomorrow evening, for instance, right? So these general laws for understanding the universe, understanding astronomy, predicting the position of planet and stars, they are applicable to any kind of object, right? On the other hand, by contrast, in design science research, we might have a managerial model, right, that is prescriptive. For instance, I can develop a managerial model for, I'm going to talk about that later, for managing engineer toward the production systems, right? So is this model universal? No, it's not. It is limited, it's limited to a range of situations. So it is prescriptive, it helps people to solve problems, and at the same time, it's not universal. It's and we must discuss that. We must discuss the applicability of solutions in design science research. Is that okay? So
we hope so. We hope so. If that was not answered, Riyadh, you can raise another question, please.
Sorry, there is another question?
No, I just because they cannot talk to us. They can only communicate with us in the chat or in the question box. So I asked. No, you can continue, Riyadh. If he has any further questions, he can raise in the chat box or in the question and answer. Yeah.
Okay, that's fine. So in this slide, I show in a very simple way the steps for design science research. So the first step, and this is very different from descriptive research, from natural sciences or social sciences, right? So the first step is to find a practical problem that is relevant and of course relevant and has research potential, right? So I need to understand this problem deeply. And at the same time, I'm going to do a literature review as in any type of research, so I can obtain an understanding about that topic from the literature, right? And the third step is to develop some kind of solution, right? So I'm going to devise something new in the world. This solution is often called artifact or solution concept. What does it mean, solution concept? It's a generic solution. It's not a solution for a specific problem, but it is a solution for classes of problems. For instance, solutions for problems faced by companies that deliver engineer to other projects, for instance, right? Fourth step, we need to evaluate that solution to see if that works, and at the same time, show the theoretical connections of that study, right? So still think about theory. It's not only about solving a problem. We still think about theory, but it's not a highly abstract theory. And finally, the final step is to examine the scope of applicability of the solution. So we must check what is the limit, what is the domain of applicability of that solution. And in this picture, I try to explain that pattern. So we have two tracks. We start with a real problem, right? Definition, understanding of a real problem. And we study the theory that exists about that topic. And then we develop the solution, the construction. And then at the end, we need to implement and test the solution. And at the same time, do a theoretical contribution. So we have two tracks to follow in parallel. So which kind of research strategies are being used in construction management? As I mentioned, many researchers position themselves as social scientists. So you see many studies that are based on surveys, case study, action research, which are research strategies that are typical of social sciences. Some people do archival analysis, for instance, stating database, data mining, and so on. Some people develop experiments. Experiment is something that the origin of experiments are in the natural sciences, right? So most of these research strategies or research methods, the origin of those methods are in either natural or social sciences. By contrast, the main outcomes of research in design science, in construction management, you can look at some examples that are in this slide, and they are very much prescriptive. So people develop problem-solving approaches, managerial models, methods for changing or intervening in a company, guidelines for improvement, process models, technical procedures, and so on. So there is a mismatch between the type of research methods we use in construction management and the kind of outcome. So if there are any students in the audience, I believe there are some, think about that. If you're using those words, those verbs in your research questions, research aims, design, build, change, improve, develop, enhance, maintain, and so on, you might be doing design science research, even if you're not aware of that, right? So think about that. So what is the problem of having this mismatch between the research methods and the aims of the research, as I mentioned before? One of the reasons for adopting these traditional ways of doing research, case studies, experiments, action research, surveys, there are so many surveys being done in the world at the moment. So people use that a lot. It's because these research methods are traditional, so they are well accepted by journals, conferences, supervisors, external examiners, and so on. And they provide a kind of safe high ground for the researchers. So I use this metaphor proposed by Donald Schoen, an author in the field of design and learning. And he used this metaphor. The researcher goes to the top of a hill where the researcher can see everything. and can describe very well what he or she is seeing. And what happens in that case is that you might do a very rigorous research study, but your study might be not very relevant because, especially in the field of engineering, because you're describing and you're describing something from far away. You don't understand the details. You don't explore how and why things work. And Donald Schoen also presents another metaphor in his paper, which is the researcher that goes to the swamp, right? So he gets lost in the swamp. He or she gets lost in the swamp. He or she gets dirty, but the researcher can actually learn from the experience of implementing something, being an insider in the company, in the construction site, and so on. Actually, Donald Schoen doesn't talk about design science research in that paper. This is an adaptation of the metaphors he used, but I think it's very much applicable for design science research. So the idea is not to abandon scientific rigor. We need to be rigorous if we want to develop good research, right? But we need to balance rigor and relevance. And I think design science research is very much about that, about finding this balance in the field of engineering or construction management, in which we need to devise solutions. We need to do prescriptive research. And this is a very important decision in a research project, right? I always tell my students, you don't need to do prescriptive research all the time. You can do prescriptive research in one research project. You can do descriptive research in another project, no problem. But you must make a conscious decision if it's descriptive or prescriptive, because everything else changes after that. So let's talk more about how you develop design science research, right? This is from a very interesting paper written by Martin Smith. It's a paper from the information systems area. And I'm going to give you a reference in these slides as well. And they say something really important. When you do design science research, you need to do two things. You need to build something new and then do an evaluation of that artifact, that new thing you developed, right? And Martin Smith, they emphasize that this new thing need to be assessed by criteria of utility, right? It needs to be something useful. It needs to be something that brings some kind of benefit, right? So this is a very important difference between design science research and descriptive research, right? We need to evaluate the utility of the artifact. This is another description, a little bit more complex. It's from this paper by Holmstrom and Kyotokifi. It's a paper from the field of operations management. And they say something I find really interesting, because in this paper, there is a clear connection between prescriptive theories and descriptive theories, right? So in design science research, there are two stages in terms of development of a solution. There is an incubation. Somebody has a completely new idea. And then that solution is refined, right? Why is it so important to emphasize that? Because some researchers are very good at incubating a solution, and some other researchers are very good at refining that solution, right? So you can divide the task. It means that many people can work in the same artifact. A very good example of solution incubation for the ones who know about lean construction, the last planner system is the most widely used planning system in the world, adopting lean ideas. So that model, that planning and control model, was incubated in the early 90s by Ballard and Howell, right? But many people after that have worked on refining that solution, right? Third stage, explanation one. What is explanation one? Is understanding why it works, right? Why the last planet system brings benefits in terms of removing waste or reducing project lead time and so on, right? So it's an assessment of utility, right? And then fourth step, you have explanation two, which is a descriptive explanation of the results, right? So it's highly abstract, right? So what I'm saying is that in the explanation part of this model, you need also different people working on these two types of explanation. One focused on the benefits and the other one focused on the validity of the theory. These are some maps of design science research, of the design science research process. I find it interesting to show that so that you don't, I make clear that it's not a linear process. So this understanding the problem, devising the solution, evaluating the solution, and so on. There are many iterations in this process, right? So you understand the problem, you devise the solution, you come back to the problem, and then to assess the solution, you revise the solution. There are many loops in this process. So this is very important to emphasize. What I'm saying is that design science research is a type of design, right? If you have some experience in design, for instance, architectural design or structural design, you know that these loops are absolutely normal in design, right? You don't understand the problem completely at the beginning. You must iterate with the development of the solution and with the evaluation. This is the research design of the research of one of my students, Cecilia Rocha. And you can see the 6 steps of design science research at the top, right? It provides you a sense of sequence at the top. But then you can see in more detail that there are many, many loops in this process, right? There are internal evaluations of the artifact, which is made by the researcher. There might be external evaluation of the artifact, which is made by potential users. And there is this cycle of refining, implementing, assessing. So you need to do that several times, as you do in a design. It's interesting because Cecilia, my student, she had to write several times. She had to revise several times this figure. So now it looks like the research process that she developed. It's definitely not something linear. So I'm going to, any questions? Any additional questions so far? Shall I move on?
Yes, please. We have just one question at the moment. by Dr. Farai from Qatar University. He's asking, what are prominent examples of classes of problems?
I'm going to give you some examples, practical examples. I think it's better. But for instance, I'll give you a quick one. For instance, project delays. Right? There are. This is a typical problem of construction projects. Right? Delays. The project is not delivered on time. So this is a problem that affects many different projects, right? So I can devise a solution for that class of problem, right? But of course, this solution is not going to be universal, it's not going to be applicable to any type of project or projects developed in any place in the world, any size, any technology. This solution is going to be applicable to a limited domain, limited range of projects. So I need to understand the problem of these classes, this specific class of project. That's the idea. Right, so I like to emphasize, let's go back to the research process. There are several steps. Here, there are several steps. I'm not going to go into detail in all steps, but I'm going to emphasize step 1, step 3, and step 4, right? The understanding the problem, developing an artifact, and assessing that artifact, right? Because these are like the most important steps. So this is something really important in design science research. Find a problem and understand deeply that problem, right? So you must find a problem that, of course, it is relevant. It should be right size. It shouldn't be a problem that is too big or something that is too small. For instance, we have a housing shortage in Brazil. I cannot use as a problem. I'm going to solve the housing shortage in Brazil. This is too big. I need to find something that I can do in a 2-year or 3-year research project, right? And when I say you need to understand deeply the problem, that means that you need to understand the problem, the context of that problem. So design science research is very much related to the context. You need to understand the context, right? And you need to understand the root causes of that problem, right? So you do a kind of descriptive study, something that is similar to what you do in social sciences and natural sciences. The difference is you don't stop just by understanding the problem, right? I like very much this sentence. A problem must be framed in a particular way. What does it mean? You need to find a problem and understand that problem from a different perspective, from a specific perspective, and preferably a different perspective. So that's the idea. That's the first step for devising something that is innovative. You need to look at the problem from a different perspective, right? One typical example, if you talk about the lean production philosophy, is the fact that many research studies have been tried to optimize the amount of inventory, right? What is the right amount of inventory? This is a topic that has been explored a lot, especially in the United States. But the Japanese looked at that problem from a completely different perspective. The idea that the inventory should be zero, or at least the inventories must be reduced towards zero all the time, right? So this is a completely different perspective in terms of solving a problem. So let's talk about step 3. Step 3 is developing a solution, right? So you design or build a solution. Of course, this solution doesn't need to be a commercial solution, right? Your research might be continued by somebody else. So you devise the solution to the stage, to the stage that is possible to reach according to your budget, according to your duration. But this is very important. You develop solution rather than you discover. Discovering is something you do in descriptive research. In design science research, you devise, you develop, you build. It must be something innovative. It must be something that is different from anything that existed before, right? And there is often, not always, but very often, there is some kind of change, some kind of improvement that is tested in the real world. Like in our research in Brazil, research on construction, we tend to work with construction companies. So they are our partners in different research projects. So we implement some of the ideas we devise in design science research, right? We do a pilot study. Sometimes we develop those solutions in partnership with the company. The technical staff, the managers of our partnering companies, they work with us to devise a solution that is suitable to that. You don't do that in social sciences or in natural sciences. And finally, you need to evaluate the solution, right? And as I mentioned before, the evaluation must be based on value, on utility to a community of users, right? So if you don't position your work as design science research, this happens quite often, right? So people they are doing some research about developing solutions, but it's not explicitly design science research. So they don't do this assessment of utility in a systematic way, right? Why? Because sometimes some researchers, they position as case studies, as action research, as surveys, and so on. So they are not explicitly dealing with the artifact, with the solution. As I mentioned before, sometimes you don't have time to fully develop the artifact, so you might do some kind of partial assessment, for instance, by using the perception of users, by using some kind of measurement, by using simulations, and so on, right? So that a wide range of techniques you can use to assess solution concept, right? It doesn't mean that it needs to be universal. It might be assessed considering or relating to a specific context. Another interesting thing about design science research, although the artifact is something very important in the research, the development of the artifact, I always like telling this to my students. even if the solution, it means the artifact, is not fully successful at the practical level, there may be still a significant theoretical implication, which means your artifact might not be that good, that useful. It might not cause the impact you have expected, but you still can get your master degree, your PhD degree. Right? Why? Because the research is not only about devising the solution, but there are also some theoretical contributions. There is a very interesting paper by a Finnish researcher from Finland, and they talk about market tests of artifacts in design science research. And his name is Kasane, and he classified market tests in 3 categories, right? First one, what he calls weak market test, right? It's the situation in which the researcher develops an artifact, implement in one company, and then he finishes his work, his or her work, leaves the company, and the company continues using the artifact, right? So this is an evidence that the artifact is useful, right? But it is a weak market test because it's used by one or a small number of companies, right? There is a second category of market test, which is when an artifact becomes widely adopted. And I have a very good example to give you, which is the last planar system, which were developed by these 2 guys in the picture, Glenn Ballard and Greg Howell. And it was developed in the early 90s, and now it's used in many different countries. In Brazil, it is widely used, in Chile, in Korea, in Scandinavian countries, UK, United States, Colombia, South Africa. So this is a very strong, although it's called semi-strong, I find that a good evidence that this planning and control model works well, right? And there is a third category of market test, which is a strong market test. It's when you demonstrate that this planning model leads to better results. And although this can be done in some specific cases, it's not very common to do that. Even the last planar systems, there are not many studies that have analyzed a large sample of projects that use the last planar system, providing evidences that it reduced so much percent the project duration or increases productivity in so much percent. It's very difficult to get this type of evidence because there are many factors that might influence those results, right? But you still can use weak market test, strong market test. You can use the perception of users. You can measure in specific projects. And this is enough for assessing the utility of an artifact. Right. So I'd like to give you some examples of artifacts, right? So you understand what I mean by an artifact, by a solution concept. In fact, there are different categories of outcomes in design science research. In his paper, Martin Smith talk about 4 types of outcomes. The first one is developing a new concept or construct. The second one, conceptual models. Conceptual models are a group of concepts that can be connected. Methods, so you can devise a method, a sequence of steps, for instance, for doing a task, for implementing something, for instance. And the fourth category is instantiation. What is an instantiation? Is the implementation of the artifact. And this is a kind of practical contribution. For instance, the Las Planas system has been implemented in thousands of companies. So these were all contributions, right? So the Las Planas system was tested in a way in a very large number of companies. There are also some other types of artifacts that are mentioned in the literature, something like technological rules. Technological rules is a kind of knowledge that can be used in a wide range of situations. It's very similar to what we call laws in descriptive research. For instance, laws of thermodynamics and so on, right? So these are prescriptions that have been tested in a large number of situations, so they can become rules. And another element that is mentioned in the literature is better theories. So if you have theories that are not only descriptive, but they can also be used as prescriptive, they are very good theories. I could mention, for instance, the Lauri Koskelas, one of the main researchers from the IGOC community. He devised the transformation, flow, and value theory, TFV theory, which is a theory that can be used for prescription. These are some examples of artifacts, and they are from studies we've done in Brazil. This is perhaps one of the first design science research studies we did, although we didn't call that design science research at that time, because it was before we had the chance to learn about this approach. So this is a model for planning and controlling safety, right? So this model enables you to integrate safety management in the Las Planas system. There are 3 different levels of planning: long-term, look ahead planning level, and short-term planning level. So the model has a number of techniques for planning safety, a number of metrics for controlling safety. It has also a number of mechanisms for participation of the workers, the foremen in this safety planning and control process, and also some mechanisms for disseminating information, right? Is it applicable to any company in the world? No, it's not. But it is applicable to companies that typically companies that deliver complex projects, companies that use lean ideas, the Las Planas system, and so on. And this is the criteria we have used to assess that model. So that model was implemented in 4 construction sites. And then we devised criteria. What is the utility of that model, the safety planning and control model? Well, it should be good for risk identification and control. It should provide some support to comply to client requirements and regulations. And it must help the integration of safety into production planning and control. Right? These were the 3 main criteria, and we use a number of evidences that enable us to test the model against those criteria. We had also criteria for applicability. So utility is one way of evaluating an artifact, but we need also a criteria of applicability. So the model must not be too expensive. It must not be too complicated. You need to be efficient. The model needs to be understandable by users, and the model must be adaptable to different contexts. We don't intend the model to be universal, but it needs to be applied to different construction projects. This is another example of a research of one of my students, Cecilia da Rocha. She did some work on mass customization, implementing mass customization in house building, right? So mass customization, it is an approach to provide flexibility in the design of houses and apartments, but at the same time be efficient, right? So she devised the main outcome, the main artifact was a conceptual framework, which could be classified as a conceptual model, right? She proposed a sequence of steps, a method for defining a customization strategy. She refined a set of concepts related to mass customization approach. So there was a conceptual contribution. And she also implemented the proposed framework in real cases. So this was the instantiation. So you can see the 4 elements or the 4 types of outcomes proposed by Martin Smith. I have some figures to illustrate. So in this table, you can see a list of concepts. For instance, customization unit was a concept that she devised. So this concept was never mentioned in any previous work. There was another concept, solution space, that was used in previous research, but she adapted that concept to the house building sector, right? So this is the examples of conceptual contributions. This is the framework. As again, I always ask my students to draw a picture of the artifact. So what are those boxes in the picture? These are the decision categories, and this decision, I mean the decision categories, and these decision categories are organized in 4 large groups: core categories, the decisions related to operations, related to the client's interface, and related to product architecture. Another thing I'd like to emphasize is the difference between doing design science research and doing consultancy or product development, right? What is the difference? In product development, in consultancy, you solve problems, right? Different types of problems. What's the difference in relation to design science research? The difference is that design science research addresses problems that are important, unique, right? So you really want to develop something new. And this artifact must have explicit linkages to theory, right? It needs to have some kind of abstract thinking, right? And the solution, as I mentioned before, is for a wide range of situations. It's not for a specific company, a specific project, a specific design. And the other difference is that research methods must be explicit, reliable, and conclusions must be found on evidences. And in fact, many studies in design science research use the same types of evidences that use, for instance, in case study research, in action research, right? The main difference is that you reposition your research. Your research is positioned as prescriptive rather than descriptive. I'll show you some examples of design science research. There are different ways of doing design science research. This is the study of actually it's a PhD thesis of Denise Brady. This thesis was developed at the University of Salford. And there was something quite interesting about this study. The fact that Denise worked for a company, a project management company that devised a planning and control model, right? Which was very much based on visual management, right? And it has some similarities to the last planner system, but it was a different planning model. And this model was implemented in the company in several projects, right? So what she did, and she was involved in some of those projects, what she did was to understand the underlying ideas of that model. And those underlying ideas became prescriptions, right? So if somebody wants to develop a planning system using visual management, this is a very interesting piece of work, right? So this is this figure in the middle is the model that she proposed based on the underlying ideas of the planning system of that company, right? And there's a picture of visual devices that have been used in some of their projects, right? So you see lots of cards, colors, division of the project in small batches, signs for constraint removal, and so on. Even this room was a place for collaborative planning. So it's a very interesting practical piece of research, and it's well positioned as prescriptive research. She did a couple of studies in Brazil in collaboration with our university. This is the work of another student, Daniela Viana. She did some work on engineer to order prefabricated building systems. And she did some work with a very large steel fabricator from South America, leading company in terms of the delivery of steel structures. And she devised, this is the research design. I'm not going to go into details, but just to point out that this was quite similar to what we called in social sciences action research. What was the difference? There was an artifact. There was something, a final outcome that could be used by other companies as a prescription, right? The study by Denise was not an action research. It was much more similar to a case study, but again, there was an artifact, right? So these are the main artifacts of the work of Daniela Viana. In the first picture on the left, you can see a list of 5 requirements for planning systems. So if you want to have a good planning system for engineered to order prefabricated building systems, you have these five requirements. And on the right, you have a kind of planning and control model, right? which is much more complex than the Las Planas system, for instance, because there are several planning levels and there are several production units. You have design, you have the manufacturing plant, you have logistics, you have construction sites, and all these planning elements need to be connected. So that's what Daniela did. She connected different planning elements into an integrated framework. So this is the prescriptive contribution. So what I expect to have in design science research in the future is a kind of tree in which we can have a wide range of research methods. Like this is an example from the education field, examples of research strategies applicable to education, right? So I'd like to see in the future research methods or research strategies positioned as design science research, which are applicable to the construction management. So I'd like to point out that design science research is not a specific type of research method, but you can have different research strategies. Right. At the conclusion, I'd like to point out the advantages of design science research and some risks, right? From the perspective of the researcher, because we're very clear about the artifact and the benefits that we expect, it is easier to get companies involved, right? I don't know how is in the Middle East, but in Brazil, companies, they don't want just descriptive studies. They don't want researchers to apply questionnaires. They have lots of demand from the academic community to do that. They're kind of fed up of doing this type of contribution without having some kind of feedback. So they want to get involved if you present good ideas. There is an additional, there is an opportunity for an additional source of evidence, right? Because you see things that work or not. And the researcher can also get some kind of training because the researcher is going to work with companies, work with implementation. For the organization, they get some practical benefits, and it is an opportunity for becoming more innovative, right? By getting involved with academic institutions, research groups, postgraduate programs, and so on. And from the point of view of knowledge, it is a way to narrow the gap between practice and research, right? So what we do is very much related to practice. And again, a significant contribution to theory can be made by a profound analysis of what works, this idea of having an additional source of evidence. What are the risks? Well, the same risks you have when you need to work with companies. Get commitment, avoid collusion of interests. You have to be very careful about that. You need to have a good agreement, making explicit what your research is going to contribute. And it is a new approach, right? So we're still finding ways of improving design science research. So I have added in my presentation some references. Some of them I have actually mentioned in my presentation, but there are also other references that represent good sources for the ones that are interested in design science research. Okay, thank you very much. I'm available for questions if there are any.